So in this video, we're learning how to rationalize denominators that have square roots. And when we're rationalizing a denominator, we're basically just trying to get the square root out of the denominator because we don't like having square roots in our denominators. So I'm going to show you guys how we can do that with example 1. So in example 1, we have 1 over the square root of 3, and our goal is to get rid of the square root of 3 in the bottom of our fraction. So we want to turn it into some rational number. So remember, rational numbers are just numbers that can be written as fractions. For these problems, we're actually going to turn the denominators into integers. So to do that, what we want to do is multiply the top and bottom of our fraction by the square root in the denominator. So I want to multiply the top and bottom by the square root of 3. And I'm going to show you guys why this works. So on the top, 1 times the square root of 3 is just the square root of 3. On the bottom, when we multiply square roots, we multiply the numbers underneath. So we multiply 3 by 3, which is 9. We put that under a square root. So now we have the square root of 3 over the square root of 9. And the square root of 9 is actually a nice number because 9 is a perfect square. So the square root of 9 is actually just 3. Now, I'm going to show you how you guys can skip this middle step of the square root of 3 over the square root of 9. So when we multiply a square root by itself, we're basically taking that square root and squaring it. Remember that square roots and squaring are inverse operations, so they cancel each other out. So when we do this, we're just going to always be left with the number underneath the square root. So we don't actually have to multiply the two numbers and then take the square root again. We'll always end up with that number under the square root. So I'll show you guys how we can apply this shortcut looking at example 2. So in example 2, we have 4 over 7 times the square root of 5. We're only trying to get rid of the square root of 5 in the denominator, so we're going to multiply the top and bottom of our fraction by the square root of 5. We don't have to multiply by 7 because we're allowed to have integers in our denominator. On the top, 4 times root 5 is just 4 root 5. And on the bottom, we have 7 root 5 times root 5. So the 7 is going to stay there, and we're going to multiply root 5 times root 5. And remember, when you multiply a square root by itself, we're just left with the number underneath. So we really have 7 times 5 on the bottom. And now we just want to simplify the bottom. So on the top, we have 4 times the square root of 5. On the bottom, 7 times 5 is 35. So we get 4 root 5 over 35 as our answer. Let's take a look at example 3, which is 2 times the square root of 7 over the square root of 2. We're trying to get rid of the square root of 2 in the bottom, so we're going to multiply the top and bottom of our fraction by the square root of 2. On the top, when we multiply 2 root 7 by root 2, we have to multiply the numbers under the root. So we'll leave the 2 on the outside, and then 7 times 2 is 14, so we get 2 times the square root of 14 on the top. On the bottom, if I multiply a square root by itself, I'm just left with the number under the root. So root 2 times root 2 is just 2. So I have 2 root 14 over 2. And now, because we have a 2 on the outside on the top of our fraction and a 2 on the outside on the bottom, right? We have a factor of 2 on the top and bottom. We can cross out those common factors. They simplify to 1. So we're just left with the square root of 14. Moving on to example 4, we have 6 times the square root of 10 over 5 times the square root of 6. You don't have to start with simplifying the roots, but I think it's going to be easier. So we can simplify the square root of 10 over the square root of 6. So we're going to keep the 6 over 5. And we can divide both of the roots by the square root of 2. So we're going to divide 10 by 2. So we're going to get the square root of 5. We're going to divide 6 by 2. And we're going to get the square root of 3. And now we want to get rid of the square root of 3 in the denominator. So we need to multiply the top and bottom of our fraction by the square root of 3. On the top, we're going to keep the 6, and we're going to multiply the numbers under the roots. So 5 times 3 is 15. So we get 6 times the square root of 15. On the bottom, we want to multiply 5 by root 3 by root 3. Remember, when we multiply a root by itself, we're just left with the number underneath. So we have 5 times 3. And now we need to simplify the bottom. So the top stays as 16 root 15. And on the bottom, 5 times 3 is 15. Finally, 6 and 15 on the outside of the roots have a common factor of 3. So we're going to divide those both by 3. 6 divided by 3 is 2. So we have 2 root 15. And 15 divided by 3 is 5. So we get 2 root 15 over 5. So for the next couple examples, I'm going to show you guys how to simplify some harder fractions that involve roots, and we're going to have to use something called the conjugate. So if we take a look at examples 5 and 6, we're going to see that we have a sum or a difference in our denominators involving a square root. So to get rid of the square roots in these problems, it's going to be a little bit more difficult than the first 4 problems. So if we look at example 5, we have 2 over the quantity of 3 plus the square root of 5. We can't just multiply by the square root of 5, and I'll show you guys why. So I'll show you guys what's going to happen if we just multiply the top and bottom by the square root of 5. On the top, we're going to get 2 root 5. On the bottom, this square root of 5 has to distribute to both things in my denominator. So I'm going to end up with a 3 root 5 plus square root of 5 times itself is just 5. And now I've just made it more complicated. I just have another root in my denominator. So that's why we can't just multiply by the root on the top and the bottom like we were doing before. So I'm actually going to erase this, and I'll show you guys how we can get rid of the root in this denominator. So what we need to do is multiply the top and bottom of our fraction by something called the conjugate of the bottom. So the conjugate means we're going to take this binomial we have in the bottom, we want to flip the sign in the middle of the two terms. So instead of 3 plus the square root of 5, we have 3 minus the square root of 5. Anything we do to the bottom of our fraction, we have to do to the top. So we also multiply the top by 3 minus the square root of 5. And I'll show you guys how this cancels out our root. So on the top, the 2 has to distribute to the 3 and the minus root 5. So 2 times 3 is 6. 2 times minus root 5 is minus 2 root 5. On the bottom, we're going to have to FOIL out these two binomials. So when we FOIL, we're going to do first. So we're going to multiply 3 by 3, which is 9. We do outer, so we multiply the 3 by the negative root 5, which is negative 3 root 5. We do inner, we multiply root 5 by positive 3, which is plus 3 root 5. And we do the last, so we multiply the root 5 by the negative root 5, and we get negative 5. Because remember, when you multiply roots by itself, we're left with the number underneath. But because we have a positive root 5 and a negative root 5, it turns into negative 5. And now what you may notice is that these two middle terms are opposites, so they're going to cancel out. And that's what we need to happen. So on the top, we still have 6 minus 2 root 5. On the bottom, because our middle terms cancel out, we're left with 9 minus 5. And when we simplify the bottom, we no longer have a root. We have 9 minus 5, which is 4. So that's why we multiply by this conjugate, because every time we do that, these two middle terms are going to cancel out, and those middle terms will always contain our roots. So we'll always just be left with some whole number or rational number on the bottom of our fraction. And now finally, we need to check if we can simplify this. Because all 3 numbers on the outside of the roots, so this 6, this minus 2, and this 4, they all have a common factor of 2. We can divide them all by 2. I'm going to show you guys why this works, because a lot of students get confused by this. So what I'm actually going to do is, let's get rid of these circles because it's going to make it look messier. I'm going to factor a 2 out of the top and bottom of my fraction. So I'm going to take a 2 out. I'm going to be left with 3 minus the square root of 5. On the bottom, I'm going to factor 4 into 2 times 2. And now remember, anytime you have a common factor on the top and bottom of your fraction, you can cancel them out. So I can cancel out these 2's. So that's why this cancellation process works. And if it's easier for you guys to always factor, I encourage you to do so, because a lot of students mess that up. So we get 3 minus root 5 on the top and 2 on the bottom. So we get 3 minus root 5 over 2 as our answer. And let's move on to example 6, which is the square root of 3 over 4 minus the square root of 2. So we want to multiply the top and bottom by the conjugate of the bottom. Remember, conjugate means just changing the sign between the two terms. So we're going to multiply by 4 plus root 2 on the top and bottom of our fraction. On the top, this square root of 3 has to distribute. So the square root of 3 times 4 is just 4 root 3. The square root of 3 times the square root of 2. We're going to multiply the numbers under the root to get the square root of 6. And on the bottom, we're going to have to FOIL 4 minus the square root of 2 times 4 plus the square root of 2. Multiply the first terms, 4 times 4 is 16. Multiply the outer terms, 4 times root 2 is plus 4 root 2. Multiply the inside terms, negative root 2 times 4 is minus 4 root 2. And multiply the last term, so negative root 2 times root 2 is going to give us a negative 2. And now these two middle terms should cancel out, so our roots cancel out on the bottom, which is what we want. On the top, we have 4 root 3 plus 6, or plus root 6, sorry. And on the bottom, 16 minus 2 is going to give us a 14. And now we need to check if we can simplify. We cannot simplify this one, and I'm going to show you guys why, because a lot of students think that we can. While the 4 and the 14 both have a common factor, the root 6 doesn't have a number on the outside that has a common factor. So basically, I can't pull out anything that this 4 root 3 and this positive root 6 have in common. I can't factor out a 2. So I can't cancel that out with the 2 that can factor out on the bottom. So you have to be able to factor out the number you're canceling out when you're canceling out things in a fraction. So I'm just going to rewrite the answer. So we end up with 4 times the square root of 3 plus the square root of 6 over 14 as our final simplified answer. Let's go through 2 more examples just to make sure we've got this down. So for these last 2 examples, I encourage you guys to try them on your own, and then you can watch me work through the problems to make sure that you solve them correctly. So in example 7, we have 10 over negative root 2 minus root 5. So this time we have 2 roots in the bottom, but we're still going to use the same method we've been using. We need to multiply by the conjugate. The conjugate says to flip the sign between the 2 terms. So we keep the negative outside of the root 2. We flip the negative between those 2 terms to a positive, and then we have root 5. Anything we do the bottom, we have to do the top. So we multiply the top by negative root 2 plus root 5. And now on the top, we're going to have to distribute this 10 in. So 10 times negative root 2 is negative 10 root 2. 10 times root 5 is 10 root 5, so plus 10 root 5. And on the bottom, we need to FOIL these 2 binomials. So if we multiply the first terms, negative root 2 times negative root 2 becomes a positive 2. So we have a 2. Multiply the outer terms, negative root 2 times positive root 5 is going to give us a negative root 10 because we multiply the numbers under the roots. Multiply the inner terms, negative root 5 times negative root 2 is going to become a positive root 10. And multiply the last terms, negative root 5 times root 5 is going to give us a negative 5. Again, our middle terms cancel out, so we got rid of the roots, which is what we want. So on the top, we still have negative negative 10 root 2 plus 10 root 5. And on the bottom, we are left with 2 minus 5. And now we just want to simplify the bottom. So I'm going to keep the top as it is. And on the bottom, 2 minus 5 is negative 3. I can't factor any common factors out of negative 10 root 2 plus 10 root 5 and negative 3 because 10 and 3 don't have any common factors. So I can't simplify this. So I'm just going to leave this as my final answer. And finally, looking at the last example, we have 1 minus root 10 over 8 plus root 3. So I need to multiply the top and bottom by the conjugate of the bottom. So I'm going to multiply by 8 minus root 3 on the top and the bottom. This time I'm going to have to FOIL the top and FOIL the bottom. So foiling the top, I need to multiply the first terms in each set of parentheses. So 1 times 8 is 8. Multiply the outer terms. 1 times negative root 3 is just negative root 3, or minus root 3. Multiply the inner terms. Negative root 10 times 8 is minus 8 root 10. And multiply those last terms. So negative root 10 times negative root 3 becomes a positive root 30. You just multiply the numbers under the roots. And now on the bottom, I'm going to FOIL 8 plus root 3 times 8 minus root 3. So multiply the first terms. 8 times 8 is 64. Multiply the outer terms. 8 times negative root 3 is minus 8 root 3. Multiply the inner terms. 8 times root 3 is plus 8 root 3. And multiply the last terms. Positive root 3 times negative root 3 is negative 3. This negative 8 root 3 and positive 8 root 3 cancel out, which is what we want. On the top, we can't combine any like terms, so we're just going to leave it as is. On the bottom, the negative 8 root 3 and the positive 8 root 3 cancel out, so we're left with 64 minus 3. And then finally, we're going to simplify the 64 minus 3. So again, we can't simplify anything on the top. We can't combine roots unless they're like roots, so we're just going to keep our answer as is. On the bottom, 64 minus 3 is 61. So we get the quantity of 8 minus root 3 minus 8 root 10 plus root 30 all over 61 as our answer. So hopefully that video helped you guys understand how to rationalize the denominator with square roots. When there's just one root in the denominator, you're just going to multiply the top and bottom of your fraction by that root. If you have some binomial in your denominator that involves a square root, you have to multiply the top and bottom by what's called the conjugate.